Hey, Rani here. Shall we make a game? And yesterday I nearly had a complete self-destruct on stream because I couldn't get this damn feature to work. And also, as soon as I press the stop button, guess what? I spotted it. So, it must have been like nearly 2 weeks ago. I was trying to get this feature working where you got a point in 3D space, trying to find the nearest point on the nav mesh. It never looked quite right. It was always like popping around all over the place. Would you look at that? It works now. I don't know what bug existed in the previous version that no longer exists, but this is doing what it's supposed to. So, for a bit of reference, just so we can put it on the record where my mistake lay, it was constraint to volume. There's a bit down here where it's sort of adding two vectors together. Where is it? Oh, I've lost it. Damn it, I've lost it. Okay, it was this here, right. So let me just bring A-Sprite up and I'll kind of draw what I did wrong and what the fix actually was. So you got a triangle like this. And this is in the case where, so we started under the surface, we then projected the point onto the surface and it ended up over an edge, right? And then we projected, hang on, no, that's not the case, right? You start over an edge, you project onto that edge, that then pushes you over another edge, and then you take this kind of like intersection, this kind of line where the two planes kind of cross over, and you basically project the point onto that line. Well, I was doing that, and you're getting the distance from there to there, fine, but then I was applying that distance to the wrong vertex, so that's why it's popping back and forth. It took me ages to find that when you include the time on stream. Yeah, once it was off stream, it didn't take very long at all. So, let's just get rid of any cruft we have left over in here. There's going to be a bit. Get rid of that. I think this is some, this is some debugging code I put in so I could, I got rid of the -1 on there. Okay, good. So, the next thing I need to change, the next thing I really need to change is, previously this kind of collision function, what it would do is, if you had, say, if you had a whole strip of triangles, what it would do is, back when it was triangles and not arbitrary polygons, if you had a point here and it was moving to there, it would actually internally, it would start here, it would notice it's passed through that wall into that triangle, it would then iterate until it got to the destination, or it slammed into a wall. But that doesn't really work for building games, because you might need to have things happen when you, say, pass through a boundary. You might have something that, you might, like, say, have like a trigger volume sort of effectively on this triangle. You might have it so that, if you've got like a surface like this and you're colliding like this, you might have a sound effect here, and then you might have the character start like, following the surface after they hit it. So this loop can't exist inside this function. Where's it gone? Yeah, this function should not have a loop in it. So we're going to get rid of that. And I was in the process of actually redesigning the output of this function. So rather than just telling you, oh yeah, we hit at least one wall, at least one floor, instead, it's going to tell you exactly what it did or didn't hit. So, and it can do that because it's only doing kind of one iteration at a time. So, performs one iteration of collision of a point moving through a navigation mesh. Yeah, that'll do. And I'm just going to make that clearer. Face origin, destination. Right. Result. I'm going to split this into 3, and this is going to become a generic sliding collision function, not just a sliding collision function. So we're going to have the results origin and the results destination. And the reason for that is that this will allow you to do both sliding and sticky collision with the same function. So I'm going to explain in these comments what is actually going on here. So the origin from which actually I need to look at the results here. What have we got? So we've got motion result none. That basically means that we didn't cross an edge or hit the surface. So that's fine. We don't need to do anything special with that. So I might need to put like a bullet list in here. Upon the yeah, I'm just gonna call it motion. It's because it does not necessarily collision, it also does other things. Okay. Mesh motion results, that's what we've called it. Performs one iteration of motion, possibly including a collision of a point through a navigation mesh. There we go. So navigation mesh, give it the face, origin, destination, result origin, result destination, and that's all we need, I think. Depending on the result. Okay, so if it's none, then equal to origin. If it's surface, equal to the point of impact. That's a good way of putting it. If it's wall, equal to the point of impact. And if it's a, yeah, so basically you've got it set up so that you've got these kind of like three special values for kind of like, you know, hitting something solid, but then we also have the entire range of, yeah, the entire range of options beyond that. So if I was going to specify the index of the face that the motion crossed into. Yeah, so it can either tell you, oh, it hit something, or it can also tell you it crossed into a, you know, into a sort of a neighboring sort of area. Equal to the point which the motion crossed into the neighboring face. There we go, that'll do. Result destination is going to be, again, depending upon the result. These are all going to be doing the same thing under the hood. It's just that contextually they're a bit different. So this means that we'll be having the kind of like loop where we're iterating over, you know, faces inside the calling code, but it means you can make decisions, you can do things that make sense for your game rather than having to depend on this loop having the right logic for you in it. I was considering other things that maybe callbacks in here, but none of them quite sat right. Okay, on the result. So none equal to destination because we didn't hit anything. Surface to destination projected onto the surface. And then we've got wall equal to destination projected onto the wall. And that's yeah, let's make it nice and clear right there. This is for sliding collision. Now we are going to be basically rewriting this function, but it's actually pretty much easier to write this code when you're doing it generically than for specifically triangles, which is nice, a nice surprise. Okay. And then destination equal to destination. Yeah, so if it crosses into a neighboring triangle, we don't do anything with it because, well, it's almost kind of, it hasn't really reached an end yet. Okay, that'll do. And I'm just going to capitalize all this. It feels a bit weird them being uncapitalized given they're kind of complete sentences. Okay. Now I just need to update all these to match. Oh yeah, I've got to test this at some point. Okay. Navigation mesh. That's now face. That's origin, destination, and result origin, result destination. Okay. And they're not constant, so we're going to be overwriting them in every case. And I'm just going to copy and paste this right over that, because it completely obsoletes it in every way. And as much as it pains me to do this, I'm just going to trash this entire function. Get out of here, punk. And I'm actually going to mention here the origin. What should happen if the origin point is outside the triangle? So let's say that you've got, let's say you've got a motion like that, right? And there's no neighbor here. What's that mean? What should that do in the grand scheme of things? Likewise, well, if you've got that, what should that do? Maybe it should throw an error. Because it's like, you're telling me to track the motion of this thing, but I don't know what you mean. I think I'm going to make it throw an error. Because I don't really know what I should do in that situation. It doesn't really make a lot of sense, does it? Okay. So, modus operandi. Let's put a, well, i.e. error, should the origin outside of the face. Okay. So what we need to do is we need to evaluate every edge, and we need to evaluate the surface, and we need to determine which is the closest one intersected. So let's say that you have something like this here. You effectively have these two planes, right, forming this triangle, kind of extending out into infinity like that. You could, and this is a terrible example. Hang on. Technically that crosses both of these planes. You've ended up on the wrong side of this plane, and you ended up on the wrong side of this plane. But you hit this one first, so this is the one we want to hit. This is the one we actually want to report as being the hit. So I guess we can reuse this, and we can initialize it to this, and then we can loop over our edges, and then we can check the surface, and we can use this to determine if something else has already generated the collision for us. Okay, I'm happy with that. So we're going to need to store the distance. Yep. And we don't need to initialize that. We'll initialize it the first time we have a collision. So we're going to have we're going to get our vertices, locations, exit normals, and surface normals. Hey, everyone's here. Everyone's here. In fact, it's actually going to be very similar to this function full stop. I might just steal this function. Yeah, let's do that. Okay, so, and anything that we don't end up using, the compiler is very good at telling us we're not using. Let's just fix that warning. Oh, if this all works and all hangs together, it's going to be so nice. It'll be such a great way of doing game collision and pathfinding. Okay. Yep, all good, all good. So yeah, we're getting a vertex location. We are getting the difference. So in this example here, we need to calculate kind of like the distance of the start and end of the line versus the line. And not just the line, but we're also adding a little bit of extra kind of tolerance on it, just so floating point stuff doesn't cause like tons of false collisions on the edge. So, hang on. So yeah, we've got the difference between that point. We have our exit normal, then we have how far over we are the line. So we need to actually do both the origin and destination difference. And I don't think we're going to be multiplying a normal just yet, so I'm going to leave that out. And yeah, I'll leave that like that for now. So origin difference goes here. And yeah, we're comparing origin point to the vertex location, and at that point we need to check whether it's over the line, and if it is, that's when we kind of throw our toys out the pram. So do our dot product. Now, what was the tolerance where she set for this? It was pretty... I think I've used it somewhere else. Oh, I've literally only... Oh, I've not actually used it anywhere else. Okay, that's fair. That's fine. In fact, I can probably move this back into here, given that we're not going to have... The reason I moved it out of this function was that I was going to be using it between the sliding and sticky collision functions. I'm not going to be doing that anymore, so they're both basically going to be the same thing there. Okay. Yeah, so origin over, if it's greater than or equal to that, yeah. Then we need to IE error. I need to bring in the header for that. And what are we putting here? Oh, don't go blank, don't go blank, don't go blank. No, don't go blank. The origin of the motion is outside of the navigation mesh. Is over a wall of the navigation mesh. There we go. Otherwise, we carry on. So we do a similar kind of thing where we're getting the distance of the destination. Oh, it's just occurred to me, I'm actually doing this. I'm actually grabbing the normal after I've used it. Okay, there we go. So, if the destination is over that line, that's when things get a little bit more interesting. Because at that point, I've done this about 15 times in this project so far, but every time I have to recheck my math. Got a point like this, and the figure we're going to get on this side is going to be like, say, 2, for example, and the figure on this side is going to be like something like 4. Well, it's going to be -4. So I want to be able to turn this into kind of like a sort of like a unit, you know, instead like 0 to 1, and then get this, which would be, hang on, it'd be like 4 divided by 2, sorry, 4 divided by 6, which is like 0.6. Right, so the way we get that is, hang on, origin over, divide by, hang on, origin over, take the destination over. There we go. Because that will be -4 divided by -4 minus 6. So yeah, that gives us the right figure. Okay, got it. We then need to compare it to this output and see if it's any closer. Or if the distance is closer than where we were last time. Yeah, there we go. This distance name is pretty bad. It shouldn't be called distance. It should be called something way more meaningful than that. Okay, so at this point, oh, it's just a thought. We can't. No, we can. We'll do the neighbor lookup later on. That's fine. I was just thinking to myself, like, can I actually say it's over that edge yet? Because one of the things is, if it hit a wall, we don't actually tell the caller which wall, and it probably should, now that I think about it. Huh. I'm going to get rid of that entirely. And instead, I am... I'm going to make it so that it's the collided with or passed through. There we go. And I changed this documentation a bit, so no longer having this wall. And there we go. Hey, that kind of worked. There, I found a way to get more more data out of this. The reason you might want that is that, say that if you sort of slammed into a wall, you might want to say have the player bounce off it. So you'd need to know exactly which wall they hit, even if you don't need to know exactly where they're going. So yeah, okay. If we're closer, then we set the output to the vertex and the closest distance to the distance. And we can throw all of this out. We don't need any of this. Very nice. That means we don't need the previous vertex or the next vertex. All of this stuff can just go away. We don't need any of that. Excellent. And at this point, we can do a nice little switch case down here. Oh, actually, what we need to do is we need to do a surface check. And we can probably also, I'm going to have to look this up again, see const pointer, because I want a pointer that I can change to data that I can't. That one. Collided normal and collided location. That'll do. There we go. Okay, so at this point we will know. Yeah, we've done our collision check here. Now we just need to do one with the surface of the nav mesh. So it's actually very similar. We don't actually need to get this vertex location at all. We can use the list of locations because it's the location of the first one. And we don't need the exit normal. We're using the surface normal instead. So at that point we have, hang on, we actually want it negative. And the reason for that is we've got a bit of extra tolerance, so we can go very slightly below the surface. Okay. Okay. And we've got we're using vertex location from vertex location, surface normal. Is that going to work? Yeah, it definitely exists. Okay, so at that point we've got the origin over there. At which point it's no longer a vertex that we're yeah, it's not the case we've got a vertex anymore. It's actually that we've hit the surface. And rather than being the exit normal, it's the surface normal. And rather than being the collided location, it's just the any point on the surface will do. Okay. All right. So now we check this. If the output is, if we haven't collided with anything on our various checks of the walls and floor, that's when we just copy the input to the output. That's what we said we were going to do, right? Yeah. So it's just a matter of doing that. So it's the origin and the result origin and destination and the result destination. Nice and easy. Otherwise, we hit something and we need to do our we need to calculate the sticky and sliding collision points. So we're going to do linear interpolation from the origin to the destination, and we're going to use the closest distance, which is actually a unit interval. Bit strange, but it'll work. And then we've got 3 axes, and we're writing it to the result origin. And for the destination, what we're doing is we have to redo some of the math we did up here, just because yeah, we're just gonna have to redo it. There's no way around it. Okay, so do a subtraction. So we're subtracting the destination from the collided location. Okay, and that gets us how far over the edge we are, and then we're going to multiply that by the normal. We should give us a vector that takes us back to the surface. And yeah, hang on. I'm thinking, ow, why am I thinking? We then add that. Yeah, that's right. We take the destination, take the multiplied normal we just made, 3 axes, and then we store that in the result destination. Okay. That will probably work. Yeah, that will probably work. Now we can actually use this to implement this line of travel thing that was actually quite complex to write before. Okay, determines whether it's possible to travel between 2 points on the average. It's not as it says. Maybe I shouldn't, though. Maybe I should still be using this. I don't actually remember if I ever tested this function. I don't think it did. Just kind of assumed it would work. Okay, how does this work? It's not that complicated, actually. So let's actually just copy these parameters over. It's actually going to be very, very, very similar to what it was before. Okay, so we've got that. We've got our... what do they call it? I think I renamed this thing I'm about to use. It is the... it's just called neighbors now. That's good. And we're just going to iterate through. If we are in the destination face, then we know we can get there. So we can just return true there. And I'm going to throw all of this logic away because it's not very good. And I'm going to replace it with this, as this probably works better, to be honest. Yeah, again, we just want to look at the first, the earliest first face that we cross and use that to determine which neighbor we've ended up in. Where is that? Oh, there it is. Where's the output variable gone? I lost it. Okay, we can also grab all these pointers. They're all very useful to us. Yep, that's good. Don't need the surface normal, don't need the edge coefficients, don't need the edge exit intersection normals. We just need the locations and the exit normals. Okay, got it. It's just going to like syntax highlight in a minute. It's making me nervous. Okay. So now we're inside a face here. We can then extract the information we actually need here. Okay, that should work. Oh yeah, this can throw as well, because again, if we're starting outside of a mesh triangle, it's ambiguous where we're trying to go. Okay, yeah. So I am reusing that edge tolerance. That's okay. That's okay. We can move it out of function. It's no big deal. Easy. I forgot to rename it and everything. What's a better name for this? Yeah, navigation mesh allows travel. There we go. That's a better name for it. Think about how it'd be used. Yeah, it'd be kind of like if navigation mesh allows travel. That makes way more sense. Okay. Where's the bit where I... There it is. Yeah, so at this point, we know exactly which one we're crossing over. And... Oh, we do actually need to do some reprojection here. We actually need a kind of like a running kind of origin. So we need to copy the origin location, origin, 3 vectors. Okay, and then we should have in here a bit where it's comparing the origin. Yep, that's good. And the destination is here, and that's going to be a destination location instead. Do I actually, hang on. No, I don't actually need to do this. I can get rid of this, and I can get rid of that error check because it's not like we're going to actually be projecting points onto the face or anything like that, which is the reason the over function throws an error. It may behave strangely if the origin point is outside the triangle, but I don't think it's actually an error. Not once worth throwing anyway. No, wait, it could still happen. We'd have a division by 0. Okay, we're good. I need to put the origin back in. Let's just call it location. I think that's better than just calling it origin. Copy from the origin location, 3 axis, location. And we don't need to... No, we do actually need to store the collide normal location because in the event that there is a neighbor, we need to... No, we don't. No. That's right. And for sliding collision, we can get rid of those. Okay. And we're just going to do linear interpolation to move the kind of location along. Yes. Oh god, I'm getting lost in my own code. Ah! Okay. All right. Okay, this is if we've hit a wall, and this is if we're going to a neighboring face. So at this point, we then do a linear interpolation from the location to the destination, closest distance, 3 to the location. Okay, that should work. Oh, it still isn't happy. What's going on here? Oh yeah, I haven't updated the, haven't copied the name of that over there. All right, we're getting there. What's this saying? What's it? Oh, missing a closing bracket off that. Oops. Missing a type definition. Where is it? That should be a float. He says writing an integer for some reason. And so should this one. And what's this saying? What doesn't this like? Oh, I'm doing the wrong kind of multiply. Hang on. I should be doing a dot product here. Okay, right. Yeah. What's going to caught that? Well, that could have led to some really strange behavior. It would take me a long time. That would have been a long rabbit hole to go searching down. Yeah. So I think might have been design mistake is making it so I could tell it how many axes I need because it's always free. It's always free. I'm definitely going to get rid of that when I do a bit of an overhaul in this engine. Okay. And I've made another mistake here, which is that this should be the collided normal. Should be the surface normal because you might be colliding with a wall. And then, what's this? There we go. So next up, oh no, we've still got more to go. Oh yeah. So this is saying that if we checked against all of the walls of the tile and we didn't get out, then, well, we're not in the tile we're trying to get to, so it must not be possible to kind of like go there in a straight line. Otherwise, we need to check the neighboring sort of tile and see if there is one over there. So I think I've got the neighbors thing here. Yep, fetch those out. So then we need to go, oh, I'm going to need to actually, yeah, I need to retrieve it. It's going to be the neighbors output and then the, oh, hang on, it's going to be the neighbors face output. So we're going like list of all the neighbors, list that's specific to this face, and then the list that's the it doesn't like that. Why doesn't it like that? For each face within, for each edge within. This is okay. It's interesting. It doesn't like that. That should be that. Okay, we're getting there. We're getting there. Whew. Expression must have pointed to object type, but it has the type motion result. Oh, that's the wrong type. That's what it's talking about. Let's rename this too. It's no longer a triangle index, it's next face. That'll do. Yeah, that's a good name for it. I like that. Okay, only a couple more errors to go. Oh, define this more than once. Yes, I have it right there. Oops. And they're identical. That was great. Great job, me. They're right next to each other. Okay, one more to go. And it's another case where I've forgotten to specify what type it is. Okay. Oh, and I still got this variable from when I was like trying to sweep the map. Okay. It's building. That's a good sign. That's a good sign. So I might hack a thing in here just so I can check that that kind of check is working. Come on. In fact, I might commit this without testing it just so I can put a bunch of test logic in it and not worry about like overwriting stuff. Overhaul of navigation mesh system to support engons. Let's bring that term back from the dead. I haven't heard that one in a while. That's gone. That shouldn't be in there. And everything here. This might possibly get rid of that soon. Get rid of these, they're not necessary. That was a dead end in my design. I need to think about that. This is our rewrite that we're about to commit. That's good. And what's this? Header changes, that's good. Added this type. I fixed a bunch of these. Not being wait, why did I change these to indexes? What? Why did I do that? That's just blatantly wrong. What? Why did I do that? Anyway, let's try making that now. Let's make sure it at least builds, even if we don't know what. Oh, it's because I changed the index type to signed. I remember now. That's why I did that. And let's go to the corresponding header file. Make the same change over there. Yeah, signed integers everywhere. I'm never doing unsigned again if I can help it. I've got a few types that still use unsigned internally, and I'm going to see if I can fix that in the engine overhaul. This got a big chunk of new functionality, didn't it? Yes, it did. Okay, so trying to think what the best way of testing this, you know, to like doing a test for this kind of like collision thing is. Don't really want to have to implement the whole sort of like, you know, agent system again. Guess I could. Guess I could. That'd be in the scenario. Let's type scenario and hang on. I'm thinking in this. It hurts. Ow, 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 ow. I would need to have the loop in here. Okay, right. So what am I going to do here? What am I going to do? Do I still have the function to find the nearest nav mesh component? Yes. So I need to I hope this works. I'm not going to end up like doing a bunch of debugging after doing this. Hang on, I'm thinking. Ow. Right, so we're coming to here. This is where we're calculating gravity. It's basically where we're doing the physics, I guess. So if we come into here and there isn't a nav mesh component ID, this is where that attachment system would come in handy. I'm thinking of making that something a bit more generic. That's when we need to actually calculate that based on the closest. Yeah. Oh, we also need to track the face. Okay, right, okay. So we have our point in 3D space. I'm just gonna make a thing here where I basically like extract the 3D coordinate. So that's going to be as simple as that. Let's make it a bit faster as well. Why not? And the previous location is going to be based on the model matrix. So I just need to get that out here. Okay, so it's going to be, hang on. It's going to be 3, 7, and 11. Because it's the last item on the first 3 rows. Yeah, I still need to do the thing where you can click in the scene and it works out where the cursor is, but I've actually got a bit closer than that off stream. Okay, all looking good. So working at the closest nav mesh component, and we have our previous point in space. We are grabbing the closest one there, and then we're grabbing the face there. Okay, that should work. And then we need to constrain it. We need to clamp it into the nav mesh so it can't, so we don't have it like spawn outside. So constrain to volume. So we're going to get the nav mesh out. I think I've got a helper in there to retrieve it. So it's get navigation mesh. There it is. Yep. Not ideal, but I might later on put this kind of in here or something. I'm not sure which yet. So we're going to constrain to the navigation mesh. Oops, no, that's a type. That's not a variable. Why do you even suggest that? C? Well, Visual Studio Code. And we have a face number. And we have a point in 3D space. And we're going to overwrite it with that. Okay, at which point we get the next point, if you follow what I'm saying, and this is where we do our iteration loop. So index iteration is 0. Let's do at most like 4. We're never going to need more than that. So this is where we're basically like we're starting here, and then it'll kind of snap to there, and then it'll kind of fall down, and if it crosses this edge, it does another collision check. So get the output. What did I call that thing? It was result, motion result? Yeah, that's the one. And we're going to something motion, right? yeah, navigation mesh motion. So we have a navigation mesh. We have a previous location. Wait, we have the face as well. I just feel like not helping today, Visual Studio Code, and like, yeah, I'm just typing stuff in, you're like, no thanks. What's going on here, man? I'm having to do all the work. We have the origin points, we have the destination points, and then it's going to write what it thinks the new location should be. So, iterated previous and iterated next. Okay, that should be okay. And then we need to do a switch on the results, and we need to check whether it's motion results none, because if it's none, we didn't hit anything, and that's good. Yep. Hang on, I'm thinking. If it's none, then we just update the model matrix with our new position. Nice and easy. And we return because we've done all the work we need to do. If it's a collision with the surface, that needs to be the edge, not the face. If it's a collision with the surface, we then need to update our previous with the, so we need to copy. Do I have it brought in the vector map header? I don't think I have. No, I haven't. So we're going to do sliding collision with the surface. So we're basically going to copy the iterated previous to previous. And we're going to iterate it next to next. We'll see if we can maybe get rid of these extra variables a bit later. We might be able to. And if it's anything else, we hit a surface. So we need to check whatever was over that edge. Result. Okay. And then here we need a constraint to volume. So yeah, we're then looking at what we're kind of like going on to next. So if that's index none, if there's, you know, if we hit a wall, it doesn't really have anywhere we can go, then we kind of like do sliding collision just like this. Otherwise, and this is why we're using the temporary variable, remember now. Otherwise, we copy the previous but not the next. And the reason for that is we want to keep moving in the same direction, but we're now inside that triangle, or face. So next thing to do is update the face number. So that's static face, is that. Now if we get to the end, you know, if we've done all our iterations and we still haven't found a good, well, that should be a break, not return. You know, if we get to the end of these iterations and we still haven't found a good candidate for, you know, we haven't reached the end of the line, we're out of iterations, that's when we need to basically, like as a safety measure, just not let the character leave the nav mesh. So we need to do a constraint to volume using our navigation mesh. And using the current face and using the next location, and we're going to overwrite the next location with that. And then we're just going to copy that across, just like that. I changed the header file, didn't I? Keep forgetting to do these parallels. I'm going to learn it eventually. Oh, we got an error. What was it? It didn't like something there. Expected an expression. Oh, it wants me to wrap this in a block. Sometimes it wants this, sometimes it doesn't. I've never quite understood why. Oh, that looks like it's building. Come on, crash. Crash. Oh, that was an error. Something link time by the looks of it. Maybe a function I haven't implemented. What is this? Oh, it's because I've commented out the implementation. I'll be honest, I'm not sure why. I don't know why I commented that out. Oh, it's using a function that got renamed. Okay. Let's also just find the definition for this, and that should be a yeah, it's a face, not a not navigation mesh triangle anymore. Slowly moving that terminology over. Oh, I'll change the header file. Time to do a parallel build. Come on. I just want to see that cube collide. Okay. Yay, a crash. What have we got? The origin of the motion is over a wall of the navigation mesh. Is it now? It should be constrained to the volume. Well, unfortunately, I'm out of time. We got pretty close to getting this work though. So tomorrow we'll almost certainly get that working, and we'll then be able to check the travel. I've got an idea how we check the travel one, and by then I might also have the kind of background work done to be able to work out where we're clicking in the scene from the mouse cursor. Thank you very much for watching, and have a great evening.